Welcome to Java Memory Management, Made Simple. In this series, we'll understand how Java actually handles memory behind the scenes. Let's begin with the basics. Where do your objects really live? Let's start with a simple question. When you write something like this, string name equals new string Roshan. Have you ever wondered, where does this object actually live? Is it in the stack or the heap? Every Java program gets its own memory area, and it's divided into two main parts, the stack and the heap. The stack keeps track of method calls and local variables, while the heap stores all the objects you create using the new keyword. We'll see how Java uses memory when a program runs. Let's watch how they come to life step by step. Now the program begins execution inside the main method. The JVM creates a stack frame for the main method. When we declare int x equals 10 semicolon, this value is stored directly in the stack memory. Primitive types like int, boolean and char always live in the stack. Now, we create a new object using the new keyword. The variable p1 is stored in the stack, but it doesn't hold the object itself. Instead, p1 stores a reference or address that points to the object in the heap. Inside the heap, the person object is created with name equals Alice and age equals 25. So the stack holds the reference, and the heap holds the actual data. When we call the constructor person, Alice 25, Java creates a new stack frame for it. Inside this frame, the parameters name and age are stored temporarily. The constructor assigns these values to the object fields in the heap. Once done, the object is fully initialized, and the constructor will soon finish execution. Once the constructor finishes execution, its stack frame is removed. But the object created in the heap remains alive. It's still connected to the reference variable p1 in the main method. This is how Java separates temporary call data from long-lived objects. Now the statement p1.showInfo is executed. A new stack frame is created for the showInfo method. This frame holds a reference to the same person object in the heap. The method reads the field's name and age from the heap and prints the message. Once the method finishes, its stack frame will be removed, but the heap object remains. Control now returns to the main method. Notice that the person object in the heap is still there. Even though the method is gone, the heap object remains accessible through p1. This shows that stack data is temporary, but heap objects live until they're no longer referenced. The object in the heap still exists, but there are no references pointing to it anymore. At this stage, the object becomes eligible for garbage collection. Java's garbage collector will reclaim the memory automatically, keeping the JVM efficient. And that's how Java handles stack and heap memory during program execution.